This would be the last identity we are going to prove. We have here the product of three reflections. We are going to use the previously proven identities as well. So please try to review the proof of the previous identities you have here in this same playlist. We're going to show that the product of three reflections is equal to the reflection of the difference of your first angle here, or theta, and then you have your second angle, which is your phi, then to add again the third angle, which is psi, in this manner. So let's try to show the proof of that, but of course let's be guided that if we talk about a reflection, okay, is equal to, you have here cosine of twice a theta, you will have here sine of twice a theta, then on the next component you will have here sine of twice theta, and you will have here negative cosine of twice theta. This will be multiplied the components of x. But we will no longer be using that because we have proven some identities already. So let's talk about this one here. Okay. We're going to show that the reflection of theta times the reflection of your phi plus the reflection of your psi, okay, would be equal to this form here. But allow us to look into this one here. We already have a proof for the product, okay? The product of two different reflections. The product of two different reflections, let's say the reflection of theta, I mean phi in this case, and the reflection of psi is actually equal to the rotation of twice the difference of their angles. So we have here the phi minus psi. We have proven this, the first identity in this proof. Okay, so in the first four videos, the first of that is talking about this. So basically, once we use that here, we can just have the reflection of theta times the rotation of twice phi minus psi. This is its equivalence. Okay, so what do we need to do now is to review the product of reflection and rotation. The product of reflection and rotation in this manner, let's me use other angles, alpha and beta. Okay, the product of a reflection and the rotation is equal to the reflection of your alpha minus your beta over 2. Okay. So in this case, our alpha is the theta, and our beta is this entire form. That would mean this would be equal to the reflection of your alpha, which is your theta, then minus your beta, which is twice phi minus psi over 2. That's over 2 here. Okay? Over 2. In this case, since we have our 2 here, you can cancel them. What will happen next is just a very simple reflection of your theta minus your phi minus your psi. Okay? Removing the grouping symbol, that's a reflection of your theta minus you have your psi, and then it's plus you have your psi here. Okay, this is now the proof, a very short proof, because we have already shown these identities as well in the previous video. We have shown that the product of three reflections would be equal to the reflection of the first angle minus the second angle plus the third angle, similar to this form. Okay, and that is for the proof of this. We might have examples related to this later on. Thank you very much for watching.